event of factor. Abnormal molar mass. Okay. In the last class, we discussed about I, event of factor. I gives you the actual in order to get I should be used for electrolytic solutes. The purpose of I, event of factor, is for electrolytic solute. That's what we discussed in the last class. So suppose if we have taken KCl, potassium chloride, I is going to be 2 because its concentration is going to become twice. Okay, is it clear? If you take calcium chloride, the I is going to be 3, right? And similarly, if you take some molecule which undergoes addition, which club together, 2 molecules club together, they undergo dimerization. I will be equal to half because you started with 2 molecules and you ended up with 1. So the final number of molecules is 1. Initial is 2. So 1 final upon initial. Is it clear?
Yes, sir.
Okay. So Aisha, last class we were discussing qualitative properties, right? And so we have the same formula. That's what we discussed. But wherever you have the concentration, you multiply it by I to get the actual value of the concentrations, actual number of particles, actual concentration of the particles. I is going to be 1 if you have non-electrolytic solute like glucose, like urea. I is going to be 1. Okay. So let me quickly uh, share the screen and move ahead, right? So this is what we discussed in the last class. Because the particles associate or dissociate their molar mass is going to calculated molar mass is going to change. Okay. So colligative properties are directly proportional to number of particles. I is proportional to number of particles. So actual number of particles divided by original number of particles. Okay. I is proportional to colligative property. So actual boiling point elevation divided by original boiling point elevation without association or dissociation. The next thing is you have I is inversely proportional to molar mass. So actual molar mass is going to come in the bottom. Observed molar mass and original molar mass before association or dissociation is going to come in the numerator. Okay. So this is what we discussed in the last class. Okay. For electrolytes which are not going complete association or dissociation, you need to take into account alpha. Alpha is going to give you the actual number of particles. Okay. And these are the formulas which are going to become for relative lowering of vapor pressure, for boiling point elevation, for freezing point depression, and for osmotic pressure. You are going to have this. Okay. So let's do this problem. What are the ideal Venta factor for the following compound? The first one is barium hydroxide, BaOH whole twice. The second one is glucose, C6H12O6. And the third one is K3PO4, potassium phosphate. And the fourth one is nitric acid, HNO3. Is it clear?
Yes,
What is
sir.
going to be the I values? Aisha, Jesslyn, Marwa, and so on. If nothing is given, you will assume that they dissociate completely, but you will consider the dissociation only of ionic compounds only. Got it? Of only ionic compounds. You will not consider the dissociation of covalent compounds. So let's do it quickly. What is going to be the answer? Jasleen has given the answer exactly correct. What about Aisha, Marwa, Ibrahim? Ibrahim, just check once more barium hydroxide. So what about Aisha? Marwa, how much? What is going to be the value of Ibrahim? You need to recheck your answer. Aisha, Marwa, what is going to be the answer? Barium hydroxide. Yeah, Ibrahim, correct. I can help you out by writing the formula. Barium hydroxide is a strong base, just like potassium hydroxide dissociate into K plus and OH minus. Barium hydroxide dissociates into barium 2 plus and 2 hydroxide ions. Got it? Similarly, this glucose is a covalent molecule. It is not an ionic compound like NaCl or KCl. You know that. Yeah, Aisha, correct. Marwa, what is going to be the answer?
Sir, it's C.
Yes, very good. So it is going to be 1 K3PO4. You have 3 potassium and 1 phosphate. So 3 potassium ions and 1 phosphate ion, PO4 3 minus. Okay, so all of you have given correct answer. That's good. And nitric acid, we know it dissociates as H plus and NO3 minus. So this get dissociated into 2 particles. So I is 2. This get dissociated into 4 ions. So I is 4. This doesn't dissociate. So if you take one molecule, it is going to remain as 1 only. And this is going to be 3. Is it clear? So this I hope is clear to you. Okay.
Yes,
So
sir.
C is the right answer. Okay. This is the next question. Which observation or observation? is related to qualitative properties. I have given the 3 observations and which are related to qualitative properties. Qualitative properties are boiling point elevation, freezing point depression, osmotic pressure, and uh, relative lowering of vapor pressure. And they come into picture if you add something, if you add some solute to a solution. Okay. So let's do this. Which observation reflect the qualitative property? This is 0.5 molar NaBr solution is having higher vapor pressure than 0.5 molar barium chloride. Yes, this is going to have the vapor pressure relative lowering is more in this case because you have 3 ions. Got it? Barium and 2 chloride. So vapor pressure will drop more. In this case, you have just 2 ions, Na plus and Br minus, so vapor pressure will drop less and vapor pressure will drop more. Got it? Is it clear?
Yes, sir.
So this is related to qualitative properties. Okay. 0.5 molar NaOH solution freezes at lower temperature than pure water. Sure, and obviously it is going to happen because NaOH is a solute, and when you add solute, the freezing point goes down. How much it goes down, by what amount it goes down, that depend upon the number of particles. So it is a colligative property. Got it? This is also a colligative property. The vapor pressure goes down with adding number of particles of solute. Okay. Let's read the third option. Pure water freezes at higher temperature than methanol. These are 2 different solvents. One is pure water, another is methanol. Got it? Clear?
Yes, sir.
So, you can start your videos also. Right? That will help me to see your response very clearly. Okay. So pure water freezes at high. So these are 2 different solvents and they are not mixed into each other. So this is not related to colligative property. Got it? This is not related to colligative property. This is just independent comparison of 2 different solvents. Okay, so colligative properties are first and second observation are related to colligative properties. Got it? I hope this is clear. Okay, right? So let's do this question. This is the numerical question. A lot of questions come up in your board examinations like this, but there you have to show the calculation. For ease, I have given the options also so that you can compare the calculations. Aluminum phosphate is there, 100% ionized aluminum phosphate. I can write the formula as Al3 plus. Aluminum is Al3 plus, and phosphate is PO4 3 minus. AlPO4. Got it? Aluminum phosphate. This is Al3 plus is the cation, and phosphate has -3 charge, which is the anion. It is 100% ionized in 0.01 molar aqueous solution. And what is going to be the value of delta TB by kb? Yes, Ibrahim, correct. Good. What about others? We will write the formula that the boiling point elevation will be equal to Kb into molality. And if the solute is electrolytic, I should write it as I. I is 2 because it is going to get dissociated into 2. And the question is asking delta TB by Kb value. That is going to be I into M, twice into molality 0.01 M. Clear? So it is going to be 0.02 molal. Right? Aisha, are you getting the answer? Marwa?
Yeah.
Okay. Very simple. This they have already given 100% ionization. Okay. So let's do this question. All of you should try this. Barium nitrate. They have given the Van't factor I. They have given. So you need to write clearly in your board examination. Then only you are going to get full marks. Okay. So I is, what is the formula for I in terms of number of particles? Ibrahim, tell me.
What's it?
What is the formula of I in terms of
Oh, okay. Number of particles before dissociation divided by number of particles after.
I is proportional to number of particles. Okay. So how many times the particles have become? Okay. After
2
association, 2 times, 3 times, 4 times. Okay. So you are
Yeah.
going to take the actual number of particle experimentally observed or actual number of particles which exist after association or dissociation. Divided by the original number of particle. Original number of particle means the amount of particles which you added, the original. Let's say, suppose if you added 1 mole of barium nitrate, okay, or 0.1 mole in this case. Original number of particles without association or dissociation. So in the numerator, so you said, Ibrahim, you said the formula incorrect. You told the, okay. So I hope you understood this. Jasleen,
Yes, sir.
Aisha, Marwa, I hope everybody understood. I is, it tells us that how many times the particles will become after association or dissociation. So you need to take the final particles upon original. Okay. So final after association or dissociation. What could be the maximum value of I for barium nitrate if it is 100% dissociated? That also you can tell. That is a separate question. Yeah, Jasleen, what could be the value of I if it is 100% dissociated? Maximum value of I for barium nitrate. maximum barium nitrate. Just imagine how it is going to get dissociated, and just imagine that how many particles from one barium nitrate it becomes how many particles after dissociation and association. Got it? So we know just I'm asking some different question, okay? Because that is very easy, so you can do that question first and this question you can do later on. I'm asking that question in this place because so that you can compare. Assuming 100% dissociation, the I can be means this barium will split into barium 2 plus. It will split into Ba2 plus and 2 nitrate ion. So I will be equal to 3. That is the maximum value. Is it clear, Ibrahim? I equal to
Yes,
3.
sir. Yes.
Jasleen, is it clear? Aisha, Marwa, is
Yes,
it
sir.
clear or not? I equal to 3, that will be the maximum. So why? So if you are taking one particle, the final concentration will be 3. We'll have the solution will have 3 particles, 1 of barium, 2 of nitrate. So if I have taken 0.1 molar, the final concentration will become 0.3 molar. Okay. But in this case, so that is a separate question. But in this case, they have given I is 2.74. So what it indicates? Maximum value of I is 3. If it is 2.74, why it is happening? Why it is less? Why the number of particles after association or dissociation have not become 3 times? What could be the reason? It may be because of the incomplete dissociation. So I hope this you understood. Due to incomplete dissociation means all the barium nitrate may have not dissociated. Some of them may have remained as it is and some of them may have dissociated. Okay. So how should I attempt this problem? Ibrahim, can you help me out?
Yes, sir. Just a second. Huh? Let me just see how I did it. Because I closed my book here.
How to do this problem? I have written the formula for I. I is actual number of particle after dissociation divided by original number of particles. So first I'm going to write the equation like this: Ba 2 plus and twice of NO3 minus. This is how it is dissociated.
Yes, sir. Yeah, that's what I did. So,
But this
degree
is
of
not
dissociation. Hmm.
this is not dissociating completely.
Yeah, it won't.
Yes, Jasleen, it could be the final answer. Yeah, we will check it, right? So if it is not dissociating completely, part of it may be dissociating. I should consider 1 minus alpha. Yeah, Ibrahim. Jasleen is also getting the same answer. Let's check it quickly. Aisha and Maro, you can try this. So let's say out of 1 mole, some amount got dissociated. Okay. Alpha got dissociated, where alpha is the degree of dissociation. So whatever get dissociated, that get dissociated into barium 2 plus, because each whatever the amount of barium nitrate dissociate, that gives the same amount of barium but twice the amount of nitrate ions. So if alpha got dissociated, the barium is going to be alpha, because each barium nitrate is having each barium, but the nitrate ions are going to be 2 alpha because the formula has 2 nitrate ions. Is it clear? So these are the final number of particles left, 1 minus alpha. This will be alpha and this will be alpha. Total number of particles will be 1 minus alpha plus 2 alpha. Got it? It is 1 plus 2 alpha. Is it clear? Marwa, is it clear or not? Aisha, is it clear?
Yes, sir.
Okay. So I is final number of particles 1 plus 2 alpha divided by original number of particle with which you started with 1. Okay, this is going to be I, and that is 2.74. okay, alpha is just subtract 1, cross multiply, subtract 1, 1.74 by 2, 0.87. Yeah. So alpha is out of 1, percentage is out of 100. Ibrahim, so I will multiply it by 100, it is going to be 87%. Okay, so you need to write the formula for I. Okay, final particles upon original particles. Okay, and for an ionic compound, you can, by the formula, you can, if it is not 100% dissociating, you can take alpha. Okay, and accordingly you can sort out. Right, this is the answer, but all of you did this question. Okay, that's good. Let's do some numericals now. So I have given you the options, but you have to write all the steps as I told you in your board examination. So 20 grams of naphthoic acid is dissolved in 50 grams of benzene. So this is naphthoic acid is solute. And solvent is okay. Just keep on writing whatever you read. So separately, that will give you, so you don't have to get back to the question again and again. Got it? So this is the solute and the solvent. And the freezing point depression, this was the formula. Delta TF, yeah, Ibrahim, equal to KF into molality. But in order to get the actual number of particles, you need to multiply it by I. And this is asking what the value of I is. Okay, the freezing point depression they have given, that is 2 Kelvin. Okay, I, which is we have to calculate, and KF value is 1.72. They have given already in the question. Molality, what you should, how you have calculated, Ibrahim, tell me. Molality, small m.
Molality, molality, that will be delta TF divided by IKF.
No, what is the formula here? We are not going to do that.
Oh, okay. The moles per unit, moles, no, moles of solute in 1 kilogram of solute.
Hmm.
Yeah.
Moles of solute. So how many moles of solute you have taken? How am I going to find it out? 20 grams are
Mole,
given.
yeah. So molecular mass I got as 172. Yeah,
Hmm.
172. The moles is
Yeah,
equal
Isha.
to given mass by
So
molecular.
yeah, 12 into 11 is how much? 132. I'm calculating the molar mass. Got it? Yeah, Isha has shared me the answer for moles, right? Okay. 8 and 32. Okay. So moles will be how many mole? 20 gram we took. Given mass by molar mass. Okay, given 140 and 132 is how much? 172. Okay, is it clear? So how many moles we took? We took correct. But you can leave it as it is also because this is getting cancelled. Okay, moles you took 20, given mass by molar mass 170. Okay. Why I have not calculated Aisha? Because this 172 and 1.72 are getting cancelled. Marwa, are you getting? These are the moles, and in this molality, what you do? You take the moles, you take the mass of solvent. In a small m, you take the mass of solvent, but that mass of solvent is benzene, but you take it in kilograms, so divided by 1000. That is just 50 grams, so divided by 1000. Got it? Clear? So let's simplify it. This 0 is going to get cancelled. This 2 is going to get cancelled. Okay. This 1.72 and 172 will get cancelled, and I should write 100. 172 by 100 and 172 got cancelled. Okay. So I is going to be yes, I will cancel zeros also. 10 by 5. I is going to be no, not 10 by 5. 1 equal to I by 5 by 10. Okay. 10I will be equal to 5. 10I upon 5. So I is equal to 0.5. Get it? Is it clear? Everybody is getting the answer. Any step if it is not clear, any discrepancy?
So can we also use the formula for from the molar mass of depression and freezing point? Like, can use that as well, right?
Yeah. Exactly. Depression and freezing point. Yeah. So I have used that only, but I have not. I have just used the original formula and I put the moles and the mass of the solid. Got it? So molality I found out by taking these are the moles of the naphthoic acid. divided by mass of benzene in kilogram, right? So with that I did. Yeah, because I cancelled a lot of things so here itself. So this is going to be the, without this cancellation, this is going to be the form in, we are going to get it in this form. 1.72 is a KF, and moles of naphthoic acid will be 20 divided by 172. And mass of benzene is 50 divided by 1000 kilogram. Okay. So we are going to simplify this one. So we are getting half as answer. So I hope everybody is getting it. Marwa, are you getting the answer? What answer you are getting? Tell me.
Sir, understood, sir.
Yeah, yeah. Just check it and let me know. Ibrahim,
Yes, sir.
what answer you are getting?
0.5.
Okay. So what it indicates if it is 0.5? If I is 0.5, somebody say, how will you interpret the value of I equal to 2? What you will say? You will say that if I for any substance is 2 means that that substance is getting splitting or ionizing into 2 ions. Is it clear? I equal to 3. If I ask you to interpret I equal to 3, like calcium chloride or BaCl2, it means that one molecule is splitting into 3 ions. But if I ask you, Jaslyn, I equal to half, okay, 0.5. So if I is half, then what interpretation should I put? How can something become half? How can something become half? Suppose if I have taken two molecules of it and they can become half of their original number. Original number is 2. When they can become half, if they are getting combined together by dimerization. Is it clear? So I started with 2 moles, but I ended with 1 mole. So I am telling what half means. I equal to half means the particles are combining together, they are undergoing dimerization, due to which the dimerization means 2 molecules combining to form 1 molecule. Okay. Because of that, the I, as we discussed earlier, I equal to final number of particles. So final, you have just 1 particle. Initially, you started with 2 particles. Got it. So I equal to 0.5 means this naphthoic acid is undergoing dimerization. Okay, the 2 molecules are combining with each other. Okay, so let's do this problem. This is also the same kind of problem which are there in NCERT, and this can be given in subjective questions. Okay, 3-mark question you can expect on this. Okay, so simple question. I have given you option the same way we are going to do it. This is also dimerized. Benzoic acid, what is the formula for benzoic acid? How it dimerizes, I can tell you also. This is benzene and COOH. This is the structure of benzoic acid. Okay, C7H6O. Ibrahim, Marwa, Aisha, Jaslin, can you tell me how can the two molecules combine together? What is the reason why they undergo dimerization? Okay, this is another molecule. So what makes them, uh, what is the force which is responsible for their combination, for their dimerization? This is oxygen. I hope everybody can see this. Okay, this is oxygen. Oxygen has partial negative charge. It has lone pairs. Hydrogen has somewhat partial is delta. Okay, delta positive means somewhat positive charge because it is connected to oxygen. So what happens? They attract each other. In the same way, this OH get attracted towards the double bond O of the benzoic acid, and this bond is known as hydrogen bonding. Or in simple, you can say it H bonding. It occurs when the H is directly connected to an electronegative atom. So H is having a positive charge and the electronegative atom is having a negative charge. They get attracted toward each other, and in this case, the two molecules combine with each other by the means of two hydrogen bonds. I have represented them by dotted lines. So is this clear? Got it?
Yes, sir.
So this is the reason for dimerization you should also keep in mind. So this dimerizes in benzene. Okay. W gram of the acid dissolves in 30 gram of the benzene. Okay. And the freezing point is equal to 2. So the freezing point depression. So the depression in freezing point equal to 2. Delta TF equal to 2. Okay. And molality, I need to figure out what is the molality. W gram of the acid is dissolved in 30 grams of benzene. If the percentage association, this is very important, 80% of it is existing in the form of a dimer. Okay, so 80%, either you can take 100 molecules, out of 100, 80 will form dimer, and those who are forming dimer are getting half as 40. It is like this, or you can continue it in this way. I will write it here, the formula also. This is the formula for benzoic acid, PHCOOH we can write, or we can write the complete structure. Two molecules, they combine together to form one. So one, if you start with one, and out of one, alpha molecules got involved in dimerization. So on this side, you will have alpha by 2, because whatever they started, they combine and form just half of the original molecules. Is it clear? Alpha is how much? What is the value for alpha in this question? That is 0.8. If it is percentage, it is out of 100. If it is degree of dissociation or association, that is out of 1. Okay, divided by 100. Percentage when you divide it by 100. So that was 80% and degree of dissociation is 0.8. Got it? Is this clear, Marwa? Jaslin, Aisha, Ibrahim?
Yes, sir.
So
Yes, sir.
Yes.
I should write as final number of particles. Final number of particles will be 1 minus alpha plus alpha by 2 divided by original number of particles. Original, if I started with 1, I should write it as 1. Okay. So I is equal to 1 minus alpha by 2. Got it? Alpha is 0.8. So 1 minus 0.8 by 2. Yes, Ibrahim. So 1 minus 0.4. So 0.6. I will put the value of I. Okay. So just check it what answer you are getting. Quickly tell me now. You need to find out the mass of acid. W gram of acid is dissolved in 30 gram of benzene. Depression in freezing point is given 2 Kelvin. Alpha is given as 0.8. Kf is given as 5. I have told you the value of I. So Ibrahim has already given me the answer. Let's check the answer from Jaslin, Marwa, Aisha. Marwa, are you getting my what I am telling?
Yes, sir.
And just ask me if anything is not clear. Okay. Anytime, all of you can stop me anytime. So just you are going to write delta TF, that is 2 equal to I already I calculated 0.6. Kf is given as 5 into molality. Molality is W by 122, which is a molar mass of the benzoic acid divided by the mass of solvent in kilograms. So 30 gram of benzene it is dissolved. This is given over here 30 gram. I will convert it by dividing it by 1000. Okay. So by simplifying it, I am going to get my answer. Got it? This is the calculation part. Moles, mass of benzene, Kf, I, delta Tf. But first write, always make it a habit to write the formula. Okay. So you don't lose the marks. First write the formula. Is it clear?
Yes.
So This is what we are doing. And we got 2.4. So lot of these questions are there in NCERT textbook, exemplar textbook from NCERT. Okay. So make sure that you are able to do this problem. If the mass is given, I will find the moles like this. Got it? Let it be W. Is it clear? Okay, this is from 11th class concept. So as of now, you can leave. This you can do. This is easy. This is not related to, not very difficult. And I hope you can do it. But there is one trick. So first you try to do your problem and then I will tell you the trick. So if the options are given, then you can apply the trick. So all of you tell me what answer you are getting. So you add some non-volatile solute. The molality is already given 0.33 mole. Okay. And if it is not given, you will take I as on. If they give you some dissociation happening, some association happening, then you need to take the I, some value of I. But in this case, if nothing, this question is not at all talking about association or dissociation. Okay. So I'm going to take I. I'm not going to take I or taking I as one, which we discussed in earlier problems also. Okay, before day before yesterday's class. Okay, last week's we discussed a lot of colligative property without I. Okay, we were taking all the solutes which were non-electrolytic, which were not undergoing association or dissociation, and because it has not mentioned anything about association or dissociation, so we are going to take the value for the I as 1. Okay, so I'm going to write the formula delta TB equal to KB into molality. Molality is already given to me. Okay, very simple. So what answer are you getting? Yeah, Aisha. Very good. Ibrahim, what about you, Jasleen? Marwa, tell me what answer you are getting. Yeah, very correct. Yeah. Do remember what they are asking. Are they asking the elevation or the boiling point? Okay. Yeah. Boiling point is going to be, okay, this this I'm going to calculate delta TV equal to kV. kV is 2.53 into molarity 0.33. Okay, that is going to be somewhere around 0.83. Okay, so this is the boiling point elevation. So what will be the actual boiling point? The boiling point will be the original boiling point plus that elevation. Okay, original is this. This is some 7.3. Okay, so yeah, or 8.3. Okay, so when you add this to this, you will get the actual boiling point. Okay, is it clear? But in this case, uh, if you want to save some time, but this is very easy. Okay, the boiling point will be greater than 80, so you can rule out these two options, because boiling point, if it is asked, because you have added a non-volatile solute, so boiling point will be higher, and because you have added very low concentration 0.33 molar. Okay, for one molar, the boiling point elevation is 2.53. Okay, so it is going to be very less value, so just slightly higher than 80 is going to be the answer. So without calculation also, in if the options are given in such a way where you can figure them out in a very clear manner, there you can solve without getting into the numerical also. But don't take the risk, do some calculation, and if this is in the board, you have to do the calculations, otherwise you are not going to get the marks. Okay, but if you are appearing for a competitive examination, there if the options are like this, then by intuition, by checking, you can quickly figure out what is going to be the answer. Otherwise, in CBSE, write the formula, write the values, okay, and try solving it. Got it? In the final answer, you are going to write it like this: TB naught equal to TB equal to TB naught plus delta T. TB naught is 80.1 and delta TB is 0.8. Got it? So these three things you are going to write. Yeah, this is also a simple problem. You can find the moles and just note it down, and I will tell you the answer. I hope everybody can do this problem. There is a theoretical question also related to ethylene glycol. This is ethylene glycol. Okay, alkylene. Let me remind you, if you talk about the name alkylene, common name alkylene. Alkylene means two same group connected on the adjacent carbon atom. Ethylene glycol means two OH groups connected on the adjacent carbon atoms. Okay. There is one theoretical very famous question about ethylene glycol, and that says why ethylene glycol is added to car radiators in cold countries. In coolants, ethylene glycol is mixed with water in cold countries, in car radiators. This is a theoretical question, 1 mark question. So what theoretical explanation you are going to give it for this? Tell me quickly. Why it is put into water along with the water and put into car radiators? Why not simply water is used? What is the use of ethylene glycol? If you use only water, the water is going to get frozen up, right? It is going to block the whole radiator. It will freeze in cold countries. Addition of ethylene glycol lowers the freezing point. Thus, it prevents the freezing of water in car radiators, because in car radiators, you know that the water should keep on circulating. Or nowadays we use coolants. Okay, a lot of coolants are there. Okay, but this is a question, so sometimes it is asked, so be careful about it. Okay, and one more example of colligative property you can write, that is very very important. Jaslin, Marwa, Ibrahim, and Aisha. That is in cold countries, salt, you must have seen maybe, salt is sprinkled. Salt you use calcium chloride is sprinkled on roads. So what is the reason? Why calcium chloride is sprinkled on roads in cold countries?
So it lowers the freezing point of water.
Yeah, it lowers the freezing point of the water and thus it prevents ice formation. Yeah, correct. And why you have used calcium chloride? Why not any? Why not NaCl, which is better? NaCl is better or CaCl2 is better?
The NaCl2 is salt only, no?
NaCl is also salt. Calcium chloride is also salt of calcium and chloride ion. So which is better for this purpose? Is it the CaCl2 better or NaCl better? I hope you are getting my point. Yeah, Justin. So CaCl2 is better. Aisha, are you getting my point or not?
Yes, sir.
Because CaCl2 has three ions. Yeah, tell me. It has three ions. Got it? CaCl2 is having three ions. So I value is 3 and delta TF lowering of freezing point will be more, and thus it is better for lowering of freezing point and thus better for prevention of formation of ice on roads. Got it? So suppose if you take NaCl, the I is 2. So freezing point, let's say, get down to -3 With calcium chloride, I'm just taking the values without calculation. For calcium chloride, there are 3 ions, and the delta TF is I into KF into molality. So because it is 3 ions, let's say the freezing point become -5. So up till -5, you will not have formation of ice on roads. So calcium chloride is a better than NaCl because it for it upon ionization it gives more ions, 3 ions. So it lowers the freezing point more by more extent. Okay, so these are theoretical questions which you can expect in your board examinations. Okay, so I hope all of you have written this question. I will tell the answer directly because this is just same. Okay, you can do the calculations. And this is very simple. Okay, no need to, but you need to do the calculations. Okay, you need to find the moles of ethylene glycol. Okay, you need to find the molality. Moles of ethylene glycol are put into 2 kg of water. So this is the molality. And now I will put the formula delta TB equal to Kf into molality, and I have taken as 1 because this is a covalent molecule. This is not like NaCl or CaCl2. This is a covalent molecule. So I will not take I as 2 or 3 or 4. Okay, just 1. I will not mention it. If it is not mentioned, means it is a covalent molecule. So 9.2. And if they ask what is the boiling point, freezing point depression, okay, or boiling point elevation or boiling point, okay, you need to get the answers very clearly. Okay, is it clear? Just read the
Yes.
question and accordingly give the answers. Right. So just do one more question. This is the application of colligative properties. Application of colligative properties was to find out the molar mass of an unknown solute. Maru, are you getting the question? Ibrahim?
Yes.
Yeah. So just try to solve it quickly. Okay, 2 gram of some unknown compound. So normally, what we do, how we find the molar mass, we put we measure that compound and we put that measured quantity, but we don't know how many moles we put because we don't know what is the molar mass. So most we can assume is 2 by m. Molar mass is as m, and benzene is 75 grams, so 75 by 1000. This is the molarity. So it is going to be 2 by m. This is the molarity. Okay. And now I'm going to put the value. Value I'm going to put as this. It reduces the freezing point from this to this value. Okay. You need to find the delta T by taking the difference. It is 0.63 equal to Kf is 5.12 into molality. Molality is 2000. Got it? And we can find the molar mass of the unknown solid. Is it clear or not?
Yes, sir.
Yes, sir.
So what answer you are getting? $216.7 we are getting approximately. Clear? This question we already did. This question. Okay. Now let's move on to the next chapter of electrochemistry. This question we already did. Okay. So electrochemistry. Uh, this chapter is about the chemical reactions and this chapter is about the interconversion of chemical energy into electrical energy or vice versa. Okay. So chemical energy is being converted to electrical energy or electrical energy is being converted to chemical energy. Chemical energy is converted to electrical energy. Okay. And this we see in our daily life where we see it. Where the chemical energy is being converted to electrical energy. Energy from a chemical reaction is used to produce electric current, where we see it in our daily life.
So batteries.
Yeah, yeah, batteries, cells, and batteries, we see it, right? In cells, we see it, and batteries, we see it, right? So these chemical reactions are spontaneous chemical reactions. Spontaneous chemical reactions which are redox in nature. What do you mean by chemical reactions? Or I should write it separately. Chemical energy generated from by carrying out spontaneous chemical energy generated by carrying out spontaneous redox reactions. That is, chemical energy is converted, their chemical energy is converted to electrical energy in cells. Okay. And this process is known as electrochemical cell. This chapter is divided into two parts. Cell is the compartment in or the container where you are doing this chemical reaction. So if the chemical energy from spontaneous redox reaction is being converted to electrical energy, then such process is known as electrochemical process, and the container or the equipment where you use this electrical energy from which the electrical energy generated is known as cell or electrochemical cell. You need to tell me what do you mean by spontaneous redox reactions. Spontaneous redox reaction. Yeah, Ibrahim, tell me. Help me out quickly.
The spontaneous redox reactions are those which happen like really quickly, or that Gibbs energy is positive.
Where
No, Gibbs energy is positive for these, yeah.
Gibbs energy change is negative.
Yeah.
Okay, I will explain it in detail, so don't worry why it is what is negative. Okay, spontaneous in a layman language, so that is more technical way of answering. Delta G is negative, that is true, but a more simpler way to answer as of now is there are certain reactions which can occur on their own once initiated, and there are certain reactions which are impossible, which can't occur on their own. There are a lot of redox reactions which can occur on their own. Got it? For example, if you take copper sulfate and if you take a more reactive metal, zinc, and you see, you all of you know it very well, and this reaction can happen on its own. You have a zinc sulfate and copper getting deposited. So this is a spontaneous redox reaction. Means it has a tendency to proceed on its own once started. Okay, and this chemical reaction is used to generate electric current. So spontaneous redox reactions, spontaneous chemical reactions are used to generate electric current in electrochemical cell. Electrochemical cell generate electric current. Okay, this is one part of the chapter. The chapter is divided into two halves. The other half is electrolytic cell. Lysis means to break something. You are breaking something, some chemical substance by passing electric current. Breaking means you are reacting it and changing it to some other compound. So electrolytic cell, it consumes electric current. Electrical energy is consumed. The reactions which we will carry out in this electrolytic cell are non-spontaneous reactions, which can't happen on their own, which are not possible. So non-spontaneous reaction, which are not feasible. Non-spontaneous chemical reactions are, because they can't happen on their own, so we need to supply electric current. Is it clear? So non-spontaneous reactions, chemical reactions are carried out by the passage of electric current. And these electrolytic cells consume chemical energy. Consume electrical energy. Or they consume electricity. With the help of electricity, they are breaking down a compound. Example is NaCl. If you put it in water, will something happen? We know nothing happens because in our food we put NaCl and water. Okay. In the preparation of food we see in daily life. So does it become HCl and NaOH? Does this happen? No. Why? HCl is a very reactive acid. NaOH is a very strong base. We can't put it on the skin. It can't. NaCl is normally, so this is a non-spontaneous reaction. Okay, or nothing happens. Let's say. Non-spontaneous, I should write. Mean they can't react on their own. So what we do, if we pass some electric current, they will start reacting in some other way. Okay, with by passage of electric current. They start breaking down. You get NaOH. Now you get NaOH. Earlier you were not getting NaOH. Okay, that HCl also break down into H2 and Cl2 because of the passage of electric current. So this is the reaction which is taking place in electrolytic cell. Electrolytic cell consume electrical energy and new chemical substances are formed. Electrolytic means, just remember it in this way. Lysis means to break. A chemical compound is broken or means it is reacted and converted to some other compound. So you need electrical energy. You need to provide the current. Electrochemical cell are the cells. This is not lytic cell, chemical cell. So chemical reactions are happening and you choose certain, not every chemical reaction can be used. Only those chemical reactions which have a tendency to proceed on their own. And there is a word for it, spontaneous. Spontaneous doesn't mean that something it happens instantly. No. Spontaneous means something which can occur on its own once initiated. Got it? So electrochemical cell spontaneous redox reactions are carried out and the chemical energy is converted to electrical energy. Got it? Is it clear? Got it? Electrolytic cell, the chemicals are already there. You break them down by passing electric current, you react. Okay, so this chapter is divided into two parts. We are doing this first part. We will start with this and then we can move on to this portion. These are two different portions of this chapter. Is it clear? Electrochemical cell. Can you give me some example of electrochemical cell? The cells and batteries, dry cell, Daniel cell, which you are going to use or which you may have used in your physics laboratory. Okay, Daniel cell, have you used it? This is Daniel cell only in your physics lab in the school. Okay, and electrolytic cell is there in car batteries. Okay, rechargeable car batteries, because the car battery has both kind of cell. Okay, it is also electrochemical when it is discharging and when it is charging, it becomes electrolytic cell. Is it clear? So this chapter is being divided into two different parts. Yes, Aisha. Galvanic cell is an example of electrochemical cell. Got it? Or galvanic cell, right? Daniel cell is example